Yeah, I think as you rightly told, simulation plays a very big role today because we have shorter to market timelines, which is very important for us to meet. Also, simulation provides us an advantage in terms of being ready with the known consequences before we actually prototype, which is both expensive and also time consuming. So one of the key takeaways was that it was very interesting to know that there is a lot of evolution happening in this area. Apart from that, a lot of counterparts and colleagues and suppliers and partners, they are all coming on board, which sort of helps us to evolve much quicker in the areas of simulation. As we heard many speakers speak today, and also which is what Volvo Group believes, is that this is an era of partnerships. There's not everything that one can do on their own. So we do believe that a strong ecosystem is very important when we are tackling the bigger topics like climate, for example, and we want to provide some solutions which make sense to a lot of people. Then we need a lot of players to be in the market. And of course, when you look at simulation and startups, I think that's really a very good combination, because not many things can be prototyped by everybody because of the lack of resources or because of lack of access to technologies. Whereas when you try to simulate, I think it gives us an opportunity to try out new things. So I think that's a very good platform for any startup to start exploring new areas. With simulation coming in, we have been able to verify a lot more things which we wouldn't have been able to verify in a conventional sense. So that's the first advantage of simulation. We also have a concept of front loading, which means that when you have a certain activity which you want to try it out, simulation gives us an opportunity to try it out much early in the life cycle. So when we do that part, I think what's also important is that we also get the learnings out of that and then make those changes as soon as possible before we really invest a lot in the prototyping. So the cost aspect comes there actually. So if you are able to try out multiple options and rule them out based on simulations and then zero in on, let's say, a couple of DOEs which you want to execute on a physical prototype, we will be making more judgment-based decisions on what's good and what's not good to try, and then thereby not waste a lot of effort and time. So the cost saving is more in terms of reducing the number of prototypes and reducing the time there again. Yeah, again here I would probably take a step back, not to put too much pressure on simulation itself or the simulation teams itself. The simulation is, as the word tells, working on a certain set of assumptions. The more robust is the assumptions, the more robust is the solution, and the robustness in assumptions comes by a lot of data which we have acquired over a period of time from the markets. So normally what happens is when we have products in the field out there giving us information in terms of their performance and their reliability, that gives us a strong basis for a good simulation. So it cannot be black and white here. I would rather say the places where we have more data about how a product is used, how the customers perceive the value, I think those will help us to make much more robust simulations. So in the sense also it comes down to, for example, as you told, fire incidents, it can happen in any type of solutions. So the whole thing is about do we understand the use case, do we understand the ambience, do we understand the market. So those are the key aspects because those are the inputs getting into simulation. The simulation itself doesn't really come out with something very, very unique if you are not giving it the right inputs. One of the initial roadblocks when we started with simulation was about acceptance of simulation as a reliable source of engineering solution provider. So basically what happens is when we do a particular simulation, how far is it correlating with the reality is always a question which comes up in the minds of people. It also is because how much computation capacity we have, how much granular can we make our models, how representative are the models to the reality. So these are the challenges, and this was not a challenge to be worried about, because in the earlier days the capacity of the computing systems we had and the capabilities of the software were not as mature as it is today. But when you look at today, we have computing power, we have maturity in the software, we have more models to work with. So it's getting better these days, and that's, I think, a good sign. Well, GT, we have been using it quite a lot in our development process, and also one of the key things what we have been doing is to sort of develop the 1D models. That has been helping us to provide some kind of a quick analysis of what could be the requirements for, let's say, cooling of an aggregate, or what could be the requirements we would need to track when it comes to managing a certain installation. So this has been some of the things which we are looking at, and then of course we used to have a lot of physical data supporting our 1D models, but once the models were correlated with the reality, I think that's when we sort of could seamlessly make incremental changes and then look at what are the effects of those incremental changes on the final products. So that's where I think a lot of value we got out of GT as a tool and as a way of working for us, that once we set a baseline, correlate the baseline with the reality, then the incremental changes could be very easily managed. But the initial effort was quite important to be done. As I told earlier in my talk, that the simulation basically represents a reality. It's basically simulating a reality in an artificial environment. So how close are we to the reality is a thing which we need to look at. So before providing a solution, I think the information about the application, the market, the type of use case, what does the customer want the product for, those are important aspects to understand. And once those understandings are clear, the next step is to see if we can simulate that environment with a good level of confidence in the virtual world. And if that is possible, then we propose the solution, and then it will normally be very successful. So if we don't do that, then probably we will be providing a solution which could potentially be quite far away from the expected realities, and then you will lose the confidence on simulation. So I think it takes a bit of effort to make sure that we have a right model and the right maturity of the model. So right now what we are looking at is installations which are covering different segments and different applications. So there are some applications for which we see that there could be challenges using a battery electric vehicle. There are segments which we think will be well served by using a fuel cell. For example, the long hauls or the overburden segments. So that's where we are looking at alternate fuels and the fuel cells as an option. So alternate fuels again is based on availability. There are some regions which are rich in biofuels. There are some regions which probably are promising for hydrogen. So we are trying to look at again market by market and segment by segment, but then trying to be ready with the products so that when the market is mature enough with the infrastructure, we have the products to introduce them. And also when it comes to fuel cell, we have a joint venture with Cellcentric, a company called Cellcentric, which is a joint venture with Daimler, where we are producing fuel cell stacks, and then the installation will be taken care by Volvo for our vehicles. And today we have a prototype which is running on our test tracks, and we are trying to characterize the performance of the fuel cell stack with reference to the expected performances from our customers. That's the current estimate. Yes, we do see that there is a lot of potential for fuel cells in the long hauls and the overburden segments where people don't have time, or the customer don't have time for frequent recharging and or let's say long haul applications where the batteries may be too heavy for the payloads.